All right, welcome to your very first class. We are going to start right away with Unit 1 factoring notes. As a reminder, this is going to go very quickly, and that is because most of this is a review of the 098 factoring content. If you need a refresher, please go to my YouTube page, Nerd Talk with Dr. Santi, and go ahead and select the 098 playlist. If you're looking for factoring videos, you'll be looking for Unit 7 notes, okay? Go through those videos. They're not very long. They're anywhere from 35 to 45 minutes. And make sure you master that content so that this goes so much easier for you. All right, I'm going to switch over to my guided notes now. Let's get into factoring. So to factor, what the hell does that mean? Well, essentially what this is saying is that when we factor an expression, we're essentially writing it as a product of factors. So like A times B times C, right? Those are products, but we write it in a way that's broken down. So factoring is essentially the reverse process of multiplication. Now you're probably thinking, well, isn't the reverse process of multiplication division? Well, yes and no. When you think about dividing, if I said to you, hey, what's 10 divided by 2? You'd be like 5. But when we factor and break a number down like 10, we don't just say it's 5, we say it's 2 times 5. That's the difference. So factoring, you break a number down, but you keep all the pieces there so that you know where you came from. Whereas opposed to division, you essentially have your final answer. You have that result from actually dividing. That's the huge difference. We don't get rid of the divisor, essentially. Good. So as a recap, so if we were to multiply 4x times x minus 3, would somebody shout out, what do you have when you distribute that 4x to both of my terms inside? Shout out, what do you have?
4x squared.
4x squared.
Minus
12.
12x.
Yes, excellent.
12x.
Minus 12x, perfect. So 4x times x, that's 4x squared. As a reminder, your product rule, keep the base, add the powers, right? We're definitely multiplying here. Then we have 4x times negative 3, which gives us that negative 12x. Now notice this one says factor. So essentially when we break down this polynomial, we say to ourselves, well, what is my GCF, right? We notice here that I have a common factor of 4. And we have a common factor of x. So I factor the 4x out of both terms. And when I divide each term by 4x, I think, well, 4x squared divided by 4x is simply x. And then negative 12x divided by 4x is negative 3. So you can see how we go back and forth between multiplying and factoring. Okay. So the greatest common factor when you're looking for your GCF, essentially, that's the product of the factors that are common to all terms in a polynomial. You cannot look at just some of them unless you're factoring by grouping. Factoring by grouping has a very specific technique, and we'll see that together as a refresher in a little bit. Let's take a look at part A. So what we're going to do here is we're going to find the GCF of each group of terms. Notice this information that I have on the side. I'm going to highlight this for you. Every term has at most 2 parts, a numerical and a variable part. When you think of factoring, please check both. You cannot just look at the numeric pieces and say you're done. You've got to look at both. Okay, so take a look at the numeric pieces of each term. We have a 12, we have an 18, we have a 24. Shout out, what is the greatest common factor of each of these? What do you think they all have in common? What number?
6.
6, definitely. 6 can go into 12, 6 can go into 18, 6 can go into 24. Super cool. 6 is part of our GCF. Notice there is no other factor greater that goes into all of these. Now let's look at each of the variables individually. We have an x to the 4th, x to the 3rd, x to the 1st power, right? If you do not see an exponent written, that is implied that it is a 1. So you can go ahead and write a 1 as the power of that x. Looking at all of those x bases, what is my GCF?
X.
Yes, a single x. We can write x to the first power if your heart desires. Essentially what that means, as a reminder, is that your first term has 4 x's to give. Your second term has 3 x's to give, but your last term only has 1. So when you think about taking x's from each term, you can only take the most that the smallest term has, right? Because you simply can't, like for instance, if you wanted 4 x's, this one's going to say, hey, I can't give you 4 x's. I've only got 3, back off. And then this one's like, yeah, I definitely can't give you 4 x's either. I only have 1. So the most you can take out of each term depends on the smallest one. Having said that, what is your GCF when it comes to your base y?
Y squared.
Yes, yes, y squared. And then finally, your base z.
1.
So we have a vote for z to the first.
No,
None.
No z, why?
it's not common to all of them.
That's correct. Notice your first term has a z. Ooh, but your second term doesn't. Gotcha. So if one of your terms does not have that same variable, you can't take it out of all of your terms. So actually your GCF is simply 6x to the first, y to the second power. Now, getting a little bit more advanced, take a look at part B. So this is similar to what you might have seen in 098, but pushing the envelope just a tiny bit. Notice each term still has 2 parts. We have a 28, the numeric part, and then we have x minus 4 to the fourth power. Here's your variable part. Each term has those 2 parts. So let's look at the numeric part first. 28, 7, 14. Shout out, what's your GCF?
7.
7, very nice. Now notice that the variable part is the same for each term. There's an x minus 4. So if we think about x minus 4 as that part that we're factoring out, at most, how many can we take?
3.
Yes, at most you can only take 3. What Shane is noticing is that there are 4 factors of x minus 4 in our first term. There are 5 factors of x minus 4 in our second term, but there are only 3 factors of x minus 4 in the last term. So that is the most we can take out of all terms. What questions do you have for me so far in factoring out the GCF? Okay, good. Hearing none. And by the way, don't be shy. Don't be shy. It does not pay to be shy in this class, I promise you. Okay? Cool. Let's actually factor out that GCF from the expression. So let's take a look at 6x to the 5th minus 4x to the 4th plus 16x x to the 3rd power. One of the first things I want you to consider is you need to always check to see if your leading term is negative. If it is, factor that negative out. Okay, keep that in mind. If your leading term was negative, you've got to factor it out. Luckily for us, it's positive. It's a positive 6x to the 5th. Your leading term is the term with the highest degree. And if you are presented these problems in order, it's typically going to be the first term, right? So we have a positive first term. Okay, take a look at each of your terms in this polynomial. I want you each to write down what you think the GCF is. Take 30 seconds. Remember, you have 2 parts to every term. Write down in your notes what you think the GCF is. Take a look at each of these. 20 seconds left. 10. Okay. Shout out what you think your GCF is.
2x cubed.
Yes, 2x cubed. Notice the power. Jose, that was excellent. Notice the power. So first, 6, 4, and 16, we can definitely factor out a 2 from all terms, and that's as high as we've got. But then I want you to consider x to the 5th, x to the 4th, x to the 3rd. Take the smallest one. Always take the smallest power. So x to the 3rd is also part of your GCF. Now, once you factor that 2x to the 3rd out, you have to now decide what's left in parentheses. What I want you to think about is saying, well, 2x to the 3rd times what gives me the original polynomial? Take another 30 seconds, fill in the parentheses. Be careful with those powers. Okay, who would like to tell me what is in the parentheses? Give me your first term only.
3x squared.
Yes, 3x squared. Someone else, give me your second term only.
2x
Good, give me a sign in front of that.
minus
Yes, beautiful. And lastly, someone else, give me your third term.
8.
Yes, give me a sign in front of that.
Sorry, plus addition.
Beautiful. Yeah, no, that's perfect. So we have 2x to the 3rd times 3x squared minus 2x plus 8. You have two factors here. You have your 2x to the 3rd, that's your first factor. Your 3x squared minus 2x plus 8, that's your second factor. This is how your factors will essentially look. Keep in mind what we wrote at the top. To factor is essentially to write an expression as a product of factors. And that's what we've done here. It's a product of the two factors. We can always check by multiplying, right? If you multiply through your factored form, you better get the original expression. That's the beauty of factoring. You can always check your work, right? I would always do that. I don't know about you, but I do typically always do that. Like for instance, I say to myself, okay, this gives me 6x to the 5th. This gives me negative 4x to the 4th. And this gives me plus 16x to the 3rd. Check. I know I did it right. I can feel confident about my answer. Just to make sure we all recall this bit of information, x to the 3rd times x to the 4th is x to the 7th. We keep the base, add the powers. Add the powers. It's a good rule to remember. This is essentially the product rule. Keep the base, add the powers. I know a lot of you remember this from last session, but it's good to have that somewhere. Good. On your own, I would like you to try part B. I'm going to give you a full minute to do this. We have 36x to the 2nd y to the 2nd z to the 3rd, plus 27x to the 3rd y to the 2nd z, plus 9x to the 2nd y z. Go ahead and factor this. Remember, take out your GCF and then go ahead and write the other factor in your parentheses. I'll give you a full minute starting now. Okay, so let's check this out. When you looked at each of these pieces, the 36, the 27, the 9, what was your GCF for the numeric component?
9.
X squared y.
9. Okay, yes. So we have 9x squared y
Z.
z. That is correct. Your GCF should be 9x squared yz. Perfect. When we factored that out from each term, someone else, what am I left with? Give me just the first term.
Would it be 4?
Keep going.
Y z 2 squared?
Yes, beautiful, Jimmy. Someone else, give me the second term.
3xy.
Yes, perfection. Plus 3xy. Very, very nice. And someone else give me my third term.
+1.
Yes, plus 1. Notice that 9x squared yz was the GCF, but that doesn't mean that that third term goes away. Remember, you're dividing that factor out of each term. So think about this idea. If you had 9x squared yz over 9x squared yz, you would say everything divides out, which leaves you with 1. Okay? And keep in mind that if you distributed, you better get the original polynomial. And we do. Very nice. What questions do you have for me before we turn the page? Okay, hearing none, let's do it. Okay, it is helpful to write each factor in a standard format. This makes canceling easier because in the end, you just need to look for exact matches. I'm like really struggling to talk today. Some important things to consider when factoring an expression are that you should essentially write the terms of the expression to be factored in the order of degree. When you think of degree, I want you to think highest power to lowest power. So let's write that. Highest to lowest power. Right? We know how to write polynomials in descending order, like x to the third plus x to the second plus x to the first plus 5, right? That's an example of a polynomial in descending order. So oftentimes it's helpful to write it in the correct format, and I'll show you what that looks like. And then, of course, when the leading term of an expression to be factored is negative, always include -1 in the GCF. The leading coefficient is the coefficient of the term in an expression with the highest degree. Okay, that's essentially the leading coefficient. The leading coefficient belongs to the term with the highest degree. Perfect. So let me show you what I mean by this. And James, are you okay? Do you have a question, or is that just from the previous problem?
I'm good.
Oh, beautiful. Okay, perfect. So let's take a look at, we have 5 minus 10x, right? We want to write this in terms of degree. So notice here that our -10x is actually a larger degree than the 5. Our 5 is a constant, whereas -10x has degree 1 because my exponent here is 1. So we're going to rewrite this as -10x plus 5. The negative belongs to the 10x and the positive belongs to the 5. Now that we've actually rewritten this expression, we can factor. So take a look at each term. We're going to look at the numeric and the variable part. Notice right off the bat that we're able to factor out a 5. Because my leading term is negative, that means I'm going to factor out a -5. Notice my first term has an x, my second one does not, so I cannot factor an x out of this polynomial. If I divide each term by a -5, what's left in my parentheses? Go ahead and shout it out.
-2x plus 1. No,
Ooh,
-1, sorry.
yes, beautiful. So we have a positive 2x minus 1, double check. -5 times a 2x is a -10x. -5 times a -1 is a +5. That's the beauty of factoring out that negative, is your signs are going to flip inside the set of parentheses. Good. Go ahead and rewrite D, write part D in descending order, and then go ahead and factor it. I'll give you a full minute starting now. And that's okay. Let's start with Shadim. Would you rewrite this polynomial in descending order for us?
Yes, gladly. -12x, parenthesis,
Wait, don't factor it. Just how do I rewrite it?
Oh, negative 12 x cubed minus 24x plus 48x squared.
Yes, except I'm going to switch those last two terms. So I'm going to switch their order and I'm going to put the 48x squared first and then the negative 24x, just so
Oh,
that
well,
your
then.
degree goes 3, 2, 1.
Copy.
Perfect, perfect, perfect. Thank you so much. Didia, when you looked at this polynomial, what did you notice right off the bat? What was something that jumped out at you?
Again, please.
Yeah, like when you looked at factoring this polynomial, what jumped out at you? What did you think you were able to factor out of this?
The GCF.
Yeah, so for that GCF, what was part of that GCF? Did you find that already?
No.
Not yet. That's okay. That's okay. Jose sent in the chat. She noticed the negative first and foremost. She noticed that our leading term had a negative. So when we factor out a GCF, that negative's got to come out, most definitely, right? And then she noticed that every term had an X, but the smallest degree, or the term that has the smallest degree, was only X to the first. So in her mind, she definitely knows right off the bat the negative comes out, and she knows that an X is going to come out. So someone else contribute to this conversation. In terms of just the numeric part, what can we factor out?
12x.
Yeah, the 12. So I'm going to factor out the negative 12. And then, of course, including that variable means that we're factoring out the negative 12x. Beautiful. All right, someone shout out, what's my first term? What's left in parentheses?
X squared.
Yeah, x squared. Beautiful. Someone else, your second term.
Negative 4x.
Yeah, negative 4x. Perfect. And your last term.
2, positive 2.
Perfect. And that is your factored form. Okay. I will tell you that you should always look at your factor in parentheses and see if you can factor further. X squared minus 4x plus 2 cannot actually be factored further. So this particular polynomial is factored completely. We're done. Okay. Moving into number 3, factoring out a common binomial expression. This is essentially the foundation for AC grouping. Essentially AC grouping and factoring by grouping. So what I'd like you all to do is first to consider numeric and variable part again. Notice we have a 9x, we have a 7. There actually is no GCF concerning the 9x and the 7, so I'm not even going to sweat that. But what you do see is that each term has the same 2x minus 3 factor. What we learned back in 098 is that because each term has the same factor, it's an expression, but it's still a factor, that we're going to factor that out of each term. So we're going to take the 2x minus 3 out of each term. If I factor out the 2x minus 3, notice that we are left with 9x plus 7. So that goes in the second set of parentheses, 9x plus 7. And that's actually done. First factor, second factor. Are you all okay with that? Okay, all right. Take a look at your second expression. This one's going to be really interesting. Let's highlight the factor that they have in common. We all see that they both have a 5x minus 1, right? Now, here's the interesting part. When we factored out this 2x minus 3, it was no big deal that we said what was left was 9x plus 7, and we threw that in the second set of parentheses. I want you to feel the same way about this. So if I factor out my 5x minus 1, what's left in the other parentheses?
Well, don't we combine them together too?
We will in just a second. You're totally right. You're seeing into the future already. How would we write it if we didn't combine it first?
3y plus 5 plus 2y plus 5.
Plus or?
Oh, it's minus. Sorry, I didn't see that.
Yes, yes, minus. Check this out. Check this out. So if we truly did factor out that 5x minus 1, look what was left. A 3y plus 5 minus a 2y plus 5. What I do want you to notice is that it was incredibly important to put the minus here and to keep the parentheses around the 2y plus 5, because when we actually subtract polynomials, we have to distribute that sign to open things up. So if we did a little bit of side work, I'm just going to shift my notes over just a touch. And any of you who've taken my own innate class, you know I do side work all the time. So we have 3y plus 5 minus 2y plus 5. We are not multiplying here, we're subtracting, which means we have to distribute the negative sign throughout the second set of parentheses. This leaves me with 3y plus 5 minus 2y minus 5. Now that we have effectively distributed that negative sign, we can officially combine like terms. Would someone else combine like terms? Tell me, what do you get?
Just be 1y.
It would just be 1y. Beautiful. Notice that the positive 5 and the negative 5, these are opposites, so they cancel each other out, leaving you with 0. So we're left with a 1y or simply a y. So my final answer is 5x minus 1. And instead of saying times y, I'm just going to throw the y in front. I don't want you to freak out. I'll write, or you could have written this as 5x minus 1 times y. All right, it doesn't matter. They're the same exact expression. I prefer to put monomials, meaning one term, that single term factor, in front of the polynomial. Totally up to you. Any questions on that so far? Check out C. Take a look at C. I'm going to put you into breakout rooms, small breakout rooms, and I want you to discuss how to approach this problem. So in each breakout room, there will be 3 people. My hope is if one has one version, another one has another, the third person will act as like a tiebreaker, okay? So I'm going to open all the rooms. Let me just check the timer. I'm going to give you only 4 minutes max. And then once the rooms start closing, it'll give you 30 seconds, okay? So I'm going to open all the rooms. Go ahead and join. I'll see you in 4 minutes. So you all had an opportunity to talk with your teammates about an approach you may take. So let me reveal to you how you would progress through this particularly challenging problem. But I think once you see it, you're gonna be like, oh, okay, that's actually not that bad. When we looked at this particular polynomial, I know for a fact the first thing that jumped out at you is the fact that they both had a common factor of 2x minus 1, right?
Yes.
The next thing you probably did was notice that this first factor has a degree of 2, right? Up to the power of 2. And this one has a degree of 3, the power of 3. So essentially what that told you is that when we go back to the idea of factoring out the variable part, you always look for the smallest power, right? So for instance, with this expression, x to the third, x to the second, x to the first, you factored out an x to the first because that was the smallest power. We're going to do the same thing for this particular polynomial. Notice the smallest power is 2. So I'm going to factor out as my GCF 2x minus 1 squared. Now, if I take 2x minus 1 squared out of both terms, that means for this first term, I'm left with the 4x minus 5. Excuse me, I didn't mean minus, the 4x plus 5. And I'm also left with minus 3. Now notice, I only factored out 2 factors of 2x minus 1, not 3, which means there's still 1 left over.
Yes.
Beautiful.
This is a lot.
This is a lot. Yes, it really is. Now, just to reiterate, I want to show you visually what this looks like. So I'm going to write something on the side that looks a little crazy. Okay, and let me spotlight my video. Give me 1 second so that I make sure that this doesn't go everywhere. I want to show to you, if you had 2x minus 1 squared times 4x plus 5, that's your first term. And then we have minus, and we have 3 times 2x minus 1 to the 3rd power. Now, if you look at the fact that your GCF is 2x minus 1 squared, because you always take the smaller of the powers, and we divide each term by 2x minus 1 squared, I want to prove to you what you're left with. This may be helpful to see. I always find visual pieces to be really, really eye-opening. Notice here we have 2x minus 1 squared over 2x minus 1 squared. So these directly cancel out. They divide out, leaving you with 1, which means we're left with 4x plus 5. Then for our second term, we have minus 3. And then notice I have 3 factors of 2x minus 1 in the numerator and only 2 factors in the denominator. So when we use the quotient rule, we subtract the power and leave it where it's heaviest. So 3 minus 2 is 1, which means these go away and you're left with just 1 of them in the numerator. This is a recollection of the quotient rule. So I'm just going to scoot this paper down for a second. And I'm going to put a note here for you. Recall. Quotient rule. If you have x to the 4th over x to the 7th, you have to subtract the powers and leave it where it's heaviest. So this actually reduces to 1 over x to the 3rd. Another example, if you had y to the 15th over y to the 3rd, again, you're going to subtract the powers and leave it where it's heaviest. 15 minus 3 is 12, so that leaves you with y to the 12th. But notice that's in the numerator. All right. This is a little side note, little something from 098 to make sure that you're understanding how to simplify bases. Tiana, does it kind of help to make that connection between the quotient rule and then how we actually applied that for this factored expression?
A little bit.
A little bit? Okay, cool. Very cool. And again, it just takes practice and we'll play around with these. And I'd be more than happy to meet with anyone who needs a little bit more assistance. Take a look at what's inside the set of parentheses. We have a 4x plus 5 minus 3 times 2x minus 1. So we are definitely going to distribute here. So we get 4x plus 5 minus 6x plus 3. Be careful with those signs. Negative, positive, make a negative, negative, and a negative, make a positive. So we just want to be really, really careful with that. Zach, can you finish this off? When you combine like terms in this expression, what does it leave you with? Just combine like terms here. Oh, you're on mute, Zach. Oh, by the way, just to let you all know, try this with me. Can you press and maybe hold your space bar?
That's what I usually do, but it's not working right now.
Yeah, mine is not working either. Weird. Okay, anyway, sorry. Go ahead, Zach.
Can you say that again? Sorry.
Yes, yes. Just combine your like terms here. What do you get when you clean this up?
10x plus
Okay.
8.
We have the 4x minus the 6.
Oh, negative 2x plus 8.
Yeah, perfect. So negative 2x plus 8, which means this entire parentheses gets replaced with the negative 2x plus 8. Bring down that 2x minus 1 squared. Okay, take a look at this carefully. I want you to look at each set of parentheses. Phil, when you look at that second set of parentheses, this one right here, anything jump out at you?
Initially, I thought, or I was going to ask if the negative sign should be in between the parentheses and not negative 2x.
Ah, okay, that's a good point. Because factoring is the product of factors, this setup is actually perfect, only because we took out that 2x minus 1 squared, and it is times whatever's left over. So when we simplified this expression within our big set of parentheses, that is what we were left with. So negative 2x plus 8, that's okay. And that negative does stay in here. But I like the fact that you're scoping out that negative, because this is an interesting piece that we have here. I guess my question to you all is, can I factor this more?
Yes.
What's your GCF?
2. -2.
Yes, a -2. So Phil was really looking at this negative and being like, there's something here, right? There's something that's going on here. When you look at both of these terms, they have a common factor of 2, but because my leading term is negative, that has to come out. So if I factor out my -2, what's left in parentheses?
+8 -4.
Okay, good. So we
Okay.
have the x, and then we do have -4. Double check. -2 times x is -2x. -2 times -4 is a +8. Beautiful. Take this factor and just throw that at the end. Okay. Now you're probably thinking, does the order of the terms matter? Yes and no. I always recommend that monomial, that single factor, that should always be in the front, right? It just looks weird if it's anywhere else. But in terms of the x minus 4 and then the 2x minus 1 squared, those don't matter in terms of their position. So for instance, I could say that my answer is -2 times 2x minus 1 squared times x minus 4. That's also acceptable. Either of those answers are perfect. Ask me your questions. What can I clarify? What do you need help with?
So,
Ooh,
you
we
can go
got
ahead, go ahead.
in summer.
Sorry. Maybe I missed something. I'm just confused why, if we're factoring it by -2 again, why we put the -2 in front
Oh, yes.
and then
Okay.
also do the 4 or x minus 4.
Yes. Okay. Great question, Summer. What ended up happening is that after we factored out that GCF and we were left with this line, this particular factored expression, what we always have to do as mathematicians is we have to break it down completely, right? So what we end up having to do, and believe me when I say you're going to end up doing this kind of thing a lot, is we have to double check to make sure that these can't be factored anymore. So like, for instance, the 2x minus 1, there's no GCF other than a 1. So we leave that alone. That one's good. But when we looked at that -2x plus 8, we definitely can factor out a -2, and you have to. So you really are going to end up, and again, because we're in 104, you're going to see this constantly. Get used to the idea of saying, oh, shoot, now I got to look at each of them to make sure I actually finished it, because this one we didn't, which is why we factored out that -2. So when I divide out that -2 from both terms, that's what leaves me with x minus 4. Beautiful. So this expression is directly the one underneath it. And that's kind of why I like stacking them, because I'm a visual person. So I like to see them, you know, right next to each other. And then I just threw that other factor right at the end. Great question. Jimmy.
I just so I get like you're distributing and everything, but what was it? I forgot. I'll come back to it.
That's okay. That's okay. I think one of the other parts that is tricky is the fact that we are literally taking out two factors of 2x minus 1, right? This is something we've never really done before. And because this term had 3 factors, that left us with 1 remaining, which is a very interesting idea. It's a very interesting concept. My advice to you all is, as you move through these problems, just move a little slower. That's it. Just move through a little bit slower and mind every step that you take as you progress through the problem so that you don't lose any of the terms or any of the signs. All right. And yeah, Jimmy, I'll come back to you if you've got that question. In the meantime, let's turn the page. Perfect. We're going to recap factoring by grouping. I love this. Typically, you're going to use factoring by grouping when essentially the number of the terms in the expression to be factored is even. When we were in 098, we only saw 4-term polynomials. But you can use factoring by grouping if you have 4 terms, 6 terms, 8 terms, 10 terms, 12 terms, etc. Right? Luckily, we won't see anything as chaotic as that. Now, just to make sure that you understand exactly how to use factoring by grouping, take a look at what we've got here. So it says, factor the following using several different groupings of pairings that have a common factor. So what I'd like us to do, and it, you know, sometimes you have to rearrange, is take a look at the polynomial, decide if the terms are laid out in a way that would be beneficial to factoring by grouping. Now, I'm going to do the first one. Go ahead and put your pens and pencils down. I just want you to watch, okay? I just want you to watch the first one. It'll be a nice refresher from your last class. Notice we have 4 terms. I've got an x to the 3rd minus 5x squared plus 2x minus 10. I'm actually happy with the order of these terms, so I'm not going to move anything around. Notice I've got my 2 x terms with higher degree next to each other, and then I've got our other 2 terms next to each other. In order to factor by grouping, if you have 4 terms, you're going to factor them 2 and 2, right? 2 terms and 2 terms. So take a look. Again, don't write anything down. I'll give you time to record this. So essentially, I'm going to look at just the first 2 terms and then just the last 2 terms. Keep in mind, whatever sign you see in the middle comes right down because we're going to separate the 2 sides. Okay. If I just look at my first 2 terms, I have an x cubed minus 5x squared. Notice my GCF is x to the 2nd power. So if I take the x to the 2nd power out of that group, I'm left with x minus 5. Let's double check. X to the 2nd times x is x cubed. X to the 2nd times negative 5 is negative 5x squared. Always that sign, plus or minus, whatever it is, that always falls right down. So make sure you always bring that sign down. Next, I have 2x minus 10. When I look at each of these terms, I see that I have a common factor of 2. So I'm going to factor that out. And if I divide a 2 out of each term, that leaves me with x minus 5. Take a second to write that down. We're not done with this polynomial, but we're almost there.
Oh, okay. Now we can square.
Okay. So I've taken the GCF out of each grouping, and that left me with an x minus 5, which is actually kind of nuts because we were just factoring out common binomial expressions. We saw this already. So I notice, okay, I have a common factor of x minus 5. So if I factored that out, notice that I'm left with x squared plus 2. And that's what goes in my second set of parentheses. If I could factor further, I would, but I'm actually done. This is as far as I can go. Any questions on my factoring by grouping of this first polynomial? Okay. Let's see what happens if the terms are just slightly moved around. Take a look at your second expression. Now, you're going to follow along with me. We're going to do this together this time. I want you to use like this bracket, so to speak. It's like an upside down bracket. I want you to identify that you're looking at the first two terms and the last two terms. Can you draw that just like I did? Cool. Melina, out of the first two terms, what's your GCF? If you just looked at these guys, what's the only thing you can take out?
X.
Yeah, X. Thank you. Sorry, Melina. So X is correct. If I take out an X, what am I left with?
X cubed plus, or squared, sorry, x squared plus.
X squared plus?
2.
Yes. If I take that X out, I'm left with x squared plus 2. All right, cool. Remember that that negative sign or positive, whatever it is, always comes down. So let's bring that down. When we look at that 5x squared and that negative 10, what's my GCF here? Yes, 5. Very, very nice. So if I factor that 5 out, and be careful, we actually factored out a negative 5 from each of these terms. What am I left with?
X squared minus 2. I'm sorry, plus 2.
Yeah, plus 2. Interesting. I switched these two terms, but it's looking like I'm able to actually factor by grouping this way. So notice we have an x squared plus 2 that's common to both. So that's my GCF. So of course I'm going to factor that out, the x squared plus 2. And then I see, oh, wait a second, I'm left with x minus 5 in my second parentheses. Aha, these are exactly the same answer, even though I switched those two middle terms around. What's happening here with this last one? Scope it out. So Summer's noticing that these are again in like a switched order. But when I wrote, well, excuse me, when I write my polynomial in this order, can I factor by grouping?
No.
No, no. Can I take anything out of the x cubed and the 10?
No.
Nothing, right? Nothing. So actually, we cannot factor in this order. We must rearrange. So sometimes you're going to be faced with polynomials that can't be factored in the order that they're given. Sometimes you may have to rewrite it, and that's okay. I don't want you to freak out if you're ever faced with an expression like that. Okay, we only have 8 minutes left of class. Now, what I'd like to do with these last 8 minutes is I'd actually like to put you into breakout rooms so that you can just talk to each other and meet each other. one of the greatest strategies for success, especially for a summer class like this that moves so quickly, is that study groups are going to be incredibly beneficial. Work groups, study groups, whatever you want to call them. Partnerships is what we really should call them. I don't want you to think that you have to do this alone. You don't, and you shouldn't, right? This is a crazy class. It's going to be intense. You shouldn't do this alone. So I'm going to put you into breakout rooms so you can at least meet some people. And then every class session, I'll try to rearrange the group so that you can meet other people. Please consider working together. It's going to be hugely beneficial to you all. All right, so let me set out some breakout rooms. I'm going to recreate these.
Are we, sorry, Doctor, are we starting the homework tonight or no?
Probably not, because we didn't really get through too much. So I would wait on that. But I will tell you that if I'm looking at the homework and I'm like, okay, these can be done, typically you and I will come up with a due date for that assignment. So I'm not going to schedule anything today, but on Thursday's class, we'll schedule all the assignments for Unit 1. Okay.
Cool, thanks.
You're very welcome. All right, I would like you to spend about 5 minutes. We'll come back for the last minute. Spend 5 minutes with your group. Just introduce yourselves, get to know each other, exchange information, right? Because you're going to probably work with these individuals, okay? I'm gonna open these rooms. Oh, cool, Melina sent her Snapchat info. If anyone wants to save that and communicate with her through Snapchat, Melina, that is awesome. It's in the chat. I'm gonna open all the rooms and then we'll come back. So let's just do, I'll leave it 4 minutes. Go for it. All right, so I truly hope that that was helpful, that you got to know somebody a little bit, at least meet them and feel a little bit more confident and comfortable. Every class session, I want to just get, give me 1 second. Every class session, I want for you to become easier and more confident. I don't want you to worry about, speaking up, saying your opinions, shouting out answers or anything like that. I need you to feel confident and willing to just give it your all and give it your best shot. All right. Any last minute questions for me? We have less than 60 seconds.
Thank you for paying attention to the clock.
Yes, of course. Of course. All right, everyone. I will see you all on Thursday. Excellent work today. Thank you so much for being ready. I will catch you all then. Shadim, I'll stay a little bit.
I do have
Thank you.
a question.
Thank you.
If you have questions, stay and I'll just answer those questions. Bye.